In the previous videos, we've been talking about a sample that we took of n equals 100. We sampled 100 students. We found an x bar of 68. And so we said our best guess is that the mean is 68 within the population. But we built in a confidence interval of, I think it was plus 0.588 for a 95% confidence interval. Okay. Now, we've so far just kind of talked about the confidence interval suggesting some level of uncertainty to our best guess here. And that's true. Now, I want to talk a little bit about the specifics of what that confidence interval says. The confidence interval, if you have been understanding it in the terms of, we are 95% sure that the true value falls within this range, you're not wildly off. So that's not specifically what the confidence interval says, but I don't want to dissuade you and say, that's wrong and you're not understanding this at all. That's roughly what the confidence interval is trying to express. It's just the specific nature of the confidence interval is slightly different. And so we're going to talk about that nuance here. But if you're coming along on the thought process, that's kind of the first step. So it's good if you're able to say, roughly speaking, we're 95% sure it's within this range. Again, that's kind of the first step into understanding the confidence interval. Second step being that that's not technically true. So let's work through the specifics. So we're going to do that here. But I wanted to point that out first, that's a common way to interpret it, and it's close. Okay, so what the confidence interval, what we built is, remember, we have found a value here of 68. Okay, happened to fall right on 68, which was handy for our math. So 68, but our confidence interval says, all right, there's some uncertainty here. So let's build a confidence interval of plus or minus 0.88, 0.588. Now, the confidence interval is again built using the idea of taking many samples. So in practice, we often take just the one sample, but just like when we were building the distribution of sampling, we thought about taking all the possible samples. Well, here, let's think about taking many samples. If we would have taken another sample, again, we're not going to get 68 every time because it's going to bounce around, right? There's sampling error, there's randomness to who gets selected. So maybe we found 68.2. That's probably too small to see, 68.2. So this time we took a sample and we found 68.2. We would build a sampling or confidence interval. It would look something like this. In fact, in this case, because we're relying upon, if we still did a sample of 100, we're using the same population standard deviation. The confidence interval is going to be the same 0.588. It's just going to have a different x bar. This will change slightly when we deal with not knowing the population standard deviation, but in this case we do know it, and so it's going to be actually the same plus or minus. So these two largely overlap, okay, but they are slightly different. We're taking a different best guess, and in fact we could think about doing this many times, right? We might get 67.6, okay, and in that case, it might look something like that. I might be drawing these, slightly off scale here, but roughly speaking, they would start to overlap sometimes, or a lot of times would kind of overlap. We would take, maybe we'd get 68 again, or maybe we'd get 68.1 or something, right? And so somewhere in this range, again, roughly. And we might occasionally get something that says, 69, let's go out a little further, 69.4. Okay, and so in that case, we're out here. Now, what does the confidence interval, or what does 95% confidence actually say? 95% confidence says if we do this many times, okay, even more than we have here, that 95% of the time, that 95% of those windows would contain the true value. Again, we don't know, and we're never going to know where the true value lies. Let's pick one, for instance. So let's say it's here. The true value is, what would that be? 60, maybe it's 68.3. Okay, in that case, 3 of our 5 windows hit it. Okay, so you could imagine this many more times, right? So maybe there's a bunch more windows down here, and it's hitting a decent amount of them. Some of them are too low, some of them are too high, but the 95% confidence interval should hit within 95% of those windows. Okay, again, we don't know that 68.3 is the true value. It could have been here, could have been here, right? We don't know exactly where it is. And in fact, when we take a single sample, we don't know where these other possible samples are, right? This 68 might have been it might have actually been this extreme value out here, and all the other samples would have us be lower. So we don't know which of these samples we're even taking when we take a single sample. But if we were to take this, if we were to take 20 samples, we'd expect 19 of them to contain the true value. And so, strictly speaking, that's closer. That's that's what the confidence interval is saying. Again, in practice, it's one of the common understanding of statistics. Often it kind of gets smushed together with this idea of 95% certain that it falls within this window. But strictly speaking, that's not quite right. So I wanted to highlight that difference here. So hopefully that helps sink it in a little bit more.